Okay, so we're going to have a fairly quick video this one. So video 1.11, primes and composite numbers. So the learning goal for this one is that students be able to solve problems involving comparison, addition and subtraction of integers. So at the end of this one, you'll want to be able to judge whether a particular number is prime or composite and reason and problem solve using the properties of prime numbers. Okay? Alright. Now, of prime concern. Now, we've been doing some prime number investigations and things at school, so you're probably well versed in some of the ideas of prime numbers, but let's just introduce a couple of extras. So they're the fundamental building blocks of mathematics. I want you to think about the tiny little Lego bricks that if you broke apart all of every number, the smallest things you're left over with the prime numbers. And mathematicians are fascinated with the way that primes interact with each other, the way they're distributed, heaps of stuff to do with prime numbers. Now, some important ways that we use prime numbers you might not think about is the idea that prime numbers are used to encrypt data sent through the internet. And one of the main ways that's seen is through an encryption type called RSA encryption. Okay, and the way that sort of starts is that two prime numbers are multiplied together, and that gets a new number. Obviously, then some other things are sort of done to that number to sort of codify the data that you send from your computer, and that comes back to yours and things. And the point is that the fact when these two primes are multiplied together, they get another number that's also hard to factorize, because its two factors are two incredibly large prime numbers, and the amount of computing power it takes to undo RSA encryption is just humongous. So it's a great way of keeping our data secure on the internet. Now, another way that we see prime numbers sort of crop up, you may not have been aware, are these cicada types called magic cicadas, or magicicada, cicadas, emerge every 7, 13 and 17 years. Now, you might recognize that as that 7, 13 and 17 are all prime numbers, and this is important because the idea is that those are prime numbers of emerging in humongous numbers, millions and millions and millions of these cicadas. And the idea is that if they emerge on 7, 13 and 17, so if I had let's get my little number line here. Okay, so 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So here's your 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And the idea is that if there's a lot of these cicadas here, and a lot of them here, and a lot of them here, and then that cycle sort of goes on again after that, when they lay their eggs will emerge at those same sort of years. The idea is, let us say there's some predators whose cycle of reproduction and maturity is maybe every 3 years or something. So every 3 years there's a lot of predators. 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 So as you can see, every 3 years a lot of predators. So as you can see, they kind of miss those big years of cicada emerging. Okay, so the cicadas miss those huge amounts of predators by being, active during these prime number years. Okay, all right. So let's have a look at what prime numbers actually are. Okay, so some key ideas. Prime number has two particular features that are important to recognize. Okay, the first being it is greater than or equal to 2. Okay, so all primes are greater than or equal to 2. So that means that, well, equal to 2 means that at least 2 is a prime number. It's our first prime number. And so let's write importantly, oops, 1 is not prime. Okay, number 1 is not a prime number. Okay, very important. Now, a prime number only has two factors, itself and 1. So for instance, let's have a look at 17. So 17 is equal to 1 times 17. That's the only way you can make 17 by using factors. Okay, can't use any other numbers, and that's special about our prime numbers. There's our two things. So it's greater than or equal to 2, and it only has two factors, itself and 1. Okay, right. So a composite number, however, is obviously every other number, but it's a number that has more than two factors. Okay, so for instance, For example, the number 4 has factors 1, 2, and 4. So it's not a prime number, it's composite. Maybe let's have a look at 15. It has factors of 1, 3, 5, and 15. Okay, and so that's what makes up our composite numbers. Okay, so one of the things you need to be able to do is recognize whether things are primes and whether things are composite. Okay, and during your investigations this term, you will have been looking at particular ways of figuring out whether things are primes and composite. Okay, so I hope you enjoyed that video. Have a look at the textbook exercises, and I'll see you at school. Thanks.